Hi, everyone. I'm Dr. Kim Arcand from the Chandra X-ray Center, which services NASA's Chandra X-ray Observatory at the Center for Astrophysics, Harvard, and Smithsonian. And today, Matt and I will be talking about NASA's Universe of Sound, which is part of the Sonifications of the Galaxy project.
Hi, and I'm Dr. Matt Russo. I run System Sounds along with my collaborator, Andrew Santaguida.
So our project today in talking about the sonifications of the galaxy is to introduce you to this project that we've been working on for about a year. We started during the pandemic as a way to connect users with data from NASA's Chandra X Observatory, as well as the Hubble Space Telescope and other orbiting observatories, particularly during a time when it was really hard to be able to connect to people and to some of our communities. What started out as a project that was meant to be able to reach people who particularly are either blind or visually impaired ended up going into this viral project that reached many millions and millions of people around the world. And I think kind of helped to show that when you make a project accessible for one group, you can really actually help make it accessible for many groups. So within about a week and a half of posting our first mixtape of sonifications, we had over 1.5 million listens on NASA's SoundCloud. We had dozens of news media stories in many different outlets and across platforms. We had millions of shares across social media and views on YouTube.
That's right. And today we're going to give you a brief overview on the sonifications we did and a bit of a deeper dive into some of our favorites from the set. So we'll start with volume 1. So in this set, we did the Pillars of Creation, M16, and that was a left-right scan. It's kind of a typical image sonification technique. It's also known as a reverse or inverse spectrogram. And with CAS-A, we did something else. We did radial paths from the central neutron star out through the nebula. And today we're going to give you a sample of the third one, which is probably our favorite of the set. Well, my favorite at least. And,
mine too.
Okay, good. And that's the Milky Way core. And so this is a left-right scan. It's like a reverse spectrogram, but it's a musical version. And so light near the top of the image is represented as higher pitched notes from a musical scale. And we have 3 telescopes contributing to this image here. Optical is Hubble, infrared is Spitzer, and X-ray is Chandra. And we assigned each one to a different instrument.
So what's really great about this data set that when you see it, you can see that there is a beautiful pocket of white sort of energetic material over on the right-hand side. And that is all the material around the supermassive black hole at our Milky Way's core. But when you hear it, when you hear the beautiful encoded sounds across all of those different cuts of energies, you can hear what a crescendo it makes as they're playing together around that very energetic region, the sort of downtown of the Milky Way galaxy, all those high energy, those high pitched beeps and boops that you're hearing just help communicate so much the impact of what's occurring in that very energetic region.
That's right. And one of the people that it impacted was none other than Apollo astronaut Michael Collins, who shared this tweet calling it unexpectedly fragile and delicate. So that was so much fun that we decided to go on and do volume 2. So in this set, we did variations on the left-right scan for the Bullet Cluster and Crab Nebula. We did slightly different techniques for each of those, different in terms of how we assign pitches to different layers, because we were trying to separate the layers in an auditory way. But the newer one in this set that's different from the rest is Supernova 1987A. So in this case, we did a different mapping. We mapped the brightness in the image to pitch. And also this is actually a time lapse. So it's really a video sonification. And this has optical from Hubble and X-ray from Chandra.
taking these images that are some of our most popular and beloved images and thinking of ways to translate them into new forms. And what's interesting about this supernova is that as it's moving from supernova to supernova remnant, essentially, there's this expanding ring and it looks kind of like a donut, right? But in actuality, it's more like a crown with all of these high energy particles kind of going up and going down. And you can hear that better in the sound than you can by just looking at this flat two-dimensional image. So I think it's another way that this sonification program just helps us express the data that we have in a really enriched way.
Yeah, and to reinforce the idea that we're kind of sampling around the ring of this debris ring of the supernova remnant, we used a crystal bowl sound. So you can imagine running your finger around. We actually made an app that will let you do this. That's in the works as well. And the sample for that crystal bowl was done by a blind musician and astronomy fan named Christine Malik.
Yeah, and we should probably add too that all of these sonifications were tested and listened to by people who are either blind or visually impaired to make sure the meaning making and the value of them made sense to the community as well. But clearly they have gone well beyond what we ever expected and have truly made an impact on a large percentage of the population that I think has been really lovely to find.
Yep, definitely. And so in set or volume 3, we tried a few new things. So with M51, the Whirlpool Galaxy, and the Cat's Eye Nebula, we did radar scans. So this is kind of like the left-right scan, except that it's going around the circle. So we're mapping the distance from the center to musical pitch. And those are also both multi-wavelength images. So there's separate layers all being combined, and you can listen to them separately as well. But the one we really like from this set is the Chandra Deep Field. And in this case, we did a color sonification. So we mapped the colors as they appear in the image into musical notes. And the colors are really representing X-ray energies over an enormous range of X-ray energies. And so using musical pitches to listen to those is actually a better approximation to the wide range of energies than the visible spectrum allows. It's about 5 octaves of X-ray energy and about 5 octaves of musical notes representing that data. And so low notes, we mapped lower energies or redder in this image, we mapped to low notes all the way up to violet. And then the whitest parts, we added some white noise for those where all the colors are combined. And we also did a vertical scan on this, and that let us use the stereo position to help localize where in the image the sounds are coming from in terms of the left-right space.
Again, I just have to say with this image, it might just look like a field of dots, right? It's the background you're seeing behind Matt right now, but it's actually the deepest X-ray image we've ever been able to obtain. And what you're hearing is essentially thousands of black holes. So you're hearing the signature of all of these energetic objects throughout our universe in a very, very deep space-time kind of way. And it's a very moving experience to hear it sonified versus to just see a field of dots. Not that that field of dots isn't beautiful, but hearing it, I think, just really projects a different kind of value to the data.
Yeah, and what we are really curious about here is exactly how people respond to these sonifications, what they get out of them, what they learn from them, if they enjoy them or not, and what we can do to improve that experience. And so to that end, we designed a user survey.
Yes, and the survey was really exciting because, again, most people don't love taking surveys. So I figured when we put it up on Twitter, we'd get a few hundred responses and I'd be thrilled. But it turned out that the survey went viral and we ended up getting about 4,500 responses within about a week and a half, almost 2 weeks. And that kind of data deluge is so welcome. We were looking for responses from people who are sighted and people who are blind or visually impaired. And we have enough of a response based on all 4,500 participants to be able to split it into essentially a 2x2 grid and looking across the expert, non-expert spectrum and the BVI and non-BVI BVI spectrum. And so far, we've had some really exciting preliminary data analysis. There are the sort of expected results of enjoyment and learning gains. What's also interesting in looking at this data is there's not actually a terribly strong split between the data between the BVI and the non-BVI community, meaning that people who are sighted and people who are not sighted had almost equal levels of enjoyment and learning from the material. And that was a really exciting finding to see, because again, it kind of backed up our original idea for this project, was to make a project that was inclusive, that took this very rich data from NASA and made it accessible and enjoyable to new audiences and in different ways.
Yeah, and we're going to use those results of the survey as we construct volume 4, which is in the works now.
It sure is. Stay tuned.
Lots more to come.